with one input R, 2-bit output, S equals S1, S0. State A is the reset state. Write Verilog code for this circuit. Okay, so we are not drawing the circuit. We're doing Verilog for it instead. So module, give it a name. Module, I'm going to call it problem 8. Problem 8. And we have an input R. We have an output. I'll call it capital S. It'll be a 2-bit output. We're going to have a clock. And we'll have a reset. And I believe that's all we have in the way of inputs and outputs. And our output, we're going to define it in an always block, so that'll be output reg. It's 2 bits, so 1:0, and I'll just call it capital S. Input is R, also clock, also reset. Put all those in there. Now, I also am going to be defining my present state and next state. You'll notice that in this particular machine, those are not things that I'm actually outputting. So when you were doing your projects in the lab, you were always outputting your states because you were lighting up LEDs. Here we're not. We're just using them internally. So they are not inputs or outputs. So how many flip-flops do I need? 2. So I will have my state will be 2 bits. So reg 1:0, and I'll have 2 of these, and I'll call one present state, and I'll call one next state. And what's that?
You could put them back to back.
I'm not sure you can, but I can because I'm writing it, and nobody's checking it.
So just in case.
Yeah, probably.
I think it's worked once. I think I coded it once and it worked.
I think it does. I don't think I would have written it on here as this is what I'm going to teach from if I wasn't 70% sure it would work. Okay, so we also can go ahead and have a parameter 1:0, and I will have A equaling the 2-bit binary number 0, and B the 2-bit binary number 1.
So in this one, since they don't give us like a state assignment, it's just whatever we want, right?
Yes, correct. I could call these whatever I wanted. And you do want to pay attention because he also mentioned 1 hot, which would mean that if this said 1 hot, then what you would have instead is, even though you could do this with 2 flip-flops, you would use 3, and A would be 2B 0 0 or 3B 0 0 1. B would be 3B 0 1 0, and C would be 3B 1 0 0. So that's.
Where would you say 1 hot?
He would say use 1 hot encoding for the state assignments.
Okay.
So
why are we using 3 flip-flops for that?
Each, there might be some reason for it. I don't know this. I'm just saying if that were the direction, then that's what you would do.
Okay.
Usually you go for minimization, but sometimes doing it like this can keep things really simple because you just, but I just was throwing that out there. Okay, so we could do that if we wanted to. Now we'll have our always block. So we'll have always, and this is our combinational, always at, and either our input R or our present state. And I'll have case will be based on our present state. And my first case will be A. And notice that this is Mealy. I have different outputs based on my input, and so I am going to define on my I'm going to go ahead and give my outputs here as I go through on each state. So if R is 1, begin, then the first thing I'll do is I'll say my next state, according to my table, if I'm in A and R is 1, my next state should be C. And S,
Do we use the
Was it next thing, not C,
So-
Next state is the little coding. Yeah.
oh, I got it, yeah.
oh, sorry. Yeah. And if R is 1, my next, my output should be the binary number 1, 0. End.
Could we also use C? Right? Like as C goes, S becomes C. Could we say that?
You could.
Right.
Yeah, it'd be weird, but you could. I mean, it's not weird, it's just that's not what it's supposed to. Yeah, but yes, you could.
Instead of the Z.
Yeah, you could. Okay, and then B. Yeah, that's a 2. Sorry. That's a 2. So B, oh wait, now I need my else. Else, so this is if R is 0, begin. And then next state becomes also C. So I could have had this outside of the if else. I could have just said case A, next state is C, and then had my if and just do my outputs on there. And S is 0, 0. And end. Okay, now for case B. So if R, begin, the next state, so for B, if R is 1, the next state is C. And our output is 1, 0. Else, our next state is A, and S is 1, 1. End. And then finally for state C, if R next state is A, and S is 0, 1. And else, begin, next state is B, and S is 0, 0. You have a question? Oh. And now, but I need a default because I did not use up all of my possibilities. And so for my default, I'll have begin, and I will have next state equals, I'm just going to say 2bxx. That's for don't care. Oops, I need that to be non-blocking. And s, also I'll have 2bxx for don't care. And then I will end case. And this would be the end of my always block. I didn't have a begin on my always block because I just had the single case statement. If I did have a begin, then I would have an end here. Now I need to have my sequential part. So this will be always at, I'm just going to say positive edge clock. It could be negative edge clock. Usually you want to check for a reset or a load. So if reset, and I think it's said to do something like this in the instructions. State A is the reset state, yeah. If reset, then present state is A, else present state is next state. And again, I didn't have a begin on my always block because I just had this single if statement here. And then I can end module. And that is my Verilog. So questions on that?